Hey guys, this is question 8 on your study guide for your quiz. We've got a parallel circuit with 3 resistors, and we are going to fill in the chart with everything about the circuit. So what I'd first start doing is just fill in what's given to you on the chart, which is our 3 resistors of 90 ohms, 45 ohms, and 180 ohms. All right, we also know our total voltage of the battery is going to be 9. So you can go ahead and do that. Next step would be to find your equivalent resistance. For a parallel circuit, your equivalent resistance formula is 1 over each of them, or the inverse of each of them. So it would be 1 over 90 plus 1 over 45 plus 1 over 180. And then you take the inverse of that total. So you can type it in your calculator, like open up your parentheses, type each of these fractions out together, close your parentheses, and then hit that inverse key, which on your calculator, there's a button that has an X and a -1, and that's the inverse key. You could also technically type it in like you would hit 90, hit that inverse key to bring up that -1, plus 45, hit that -1, plus 180, hit that -1. And again, put all that in parentheses and then hit that -1 again. And you should get the same answer. Definitely test out each way of typing it in and see which way you like. It's a lot faster to hit that inverse key than typing in all the fractions, but do whatever is comfortable for you. So your answer there should be 25.7, and that's of course rounded. And that is your equivalent resistance. So you can add that to your chart. All right, next step is going to be to find your current. So you're going to use Ohm's law, which is voltage equals current times resistance. That I stands for current. So you'd plug in the 9, solve for I, and then plug in your equivalent resistance that you just found of 25.7. You would divide 9 by 25.7. So that would equal 0.35 amps. All right, so we can add that now to our chart. Now, in a parallel circuit, your voltage stays the same through each branch, and our current changes. And make sure you get that down. One way that I remember this is, it's kind of strange, but for a series circuit, I just remember SC, like South Carolina. For parallel, I remember VP, like vice president. So I think voltage is the same in parallel, in a series, current's the same, so South Carolina vice president. If that helps you, then great, that's how I remember it. So your voltage is the same in parallel, so 9 volts go all the way down. So that's all the same. And then we can solve for current would be the last thing, and we're going to use that Ohm's law formula again. So you'd plug in your 9 volts, solve for I, plug in each resistance. So 90, plug in your 45, and then plug in your 180, and these are all separate, of course. So I went ahead and plugged in each of them. You would have, when you would divide 9 by 90 would give you 0.1, 9 by 45 would give you 0.2, and 9 by 180 would give you 0.05. So those are the currents for each. All right, so that's everything in our chart. So to recap, first thing to do, I'd fill in your chart with what is given to you in your diagram, which was our 3 resistances and our voltage. Then go ahead and find your equivalent resistance using the appropriate formula. In this case, we're parallel, so we're using the parallel formula. Note the P in the formula. That gave us this 25.7. We then used Ohm's law to get our total current in the circuit, which was 0.35 amps. And then since we are a parallel circuit, the voltage is what stays the same through each branch. So that's 9 volts all the way down. Then we used Ohm's law again to find the current in each resistor. The total of each of your resistors, the current of them actually adds up to equal our total here as well. And that's what you should see. It may be slightly off if we needed to round a little bit, but in this case we didn't have to round, and it does equal indeed. So I hope this video helps you. Please let me know if you guys have questions on solving these circuit problems.